Inverse graphs are awesome. They're simple. You don't have to do much. You just have to change the y to x and the x to y. So when they give you a graph like this, it's a pretty simple graph, there's only 4 points, and it says you're supposed to sketch the inverse given the graph, then the best thing to do is just make a little table, record your points, and then switch them. So I can make my little table, y equals f of x on this side, and I can make this one x equals f of y. If that doesn't blow your mind too much, that's what we're going to be doing. We're going to be switching them. So first point is at negative 5 and 1. So it's going to be 1 and negative 5. See how I just switched them? All right. Second point is at negative 2 and 4. So guess what? It's going to be at 4 and negative 2. Isn't this fun? Now, the next point is at 0 and 1. I particularly like those ones because they're easy anchor points on the axes. And then the next one is 4 and 0. So those ones are awesome. And the reason why they're awesome is because now, I don't really have to look at this anyway, but what I'm going to do is draw these points on there. And it's pretty easy to see where they're going to go. So this one's 1 and negative 5. So it's 1 and negative 5. That one's not so easy to visualize, at least not for me. 4 and negative 2. So 4 and negative 2. It's really helpful for me to have, wait a minute. Okay, see? It's just blowing me away. It's like, I don't understand. It's not, my brain's not really getting it. Just to flip it on the page, this really helps to lay it out. However, these ones, 1 and 0, 1 and 0, that I can see because I just went like that, right? And this one is 0 and 4, so 0 and 4, that one just got flipped like that. So the ones that are on the axes, for me anyway, are easier to visualize that they've been flipped. So now I'm just going to connect the points. Try not to be too messy here. Whoops. So much for not being messy. Right. So you can see that if I had taken a line down the middle of the y equals x, where 1 and 1, negative 2, whatever, they all go this guy, and they like to dot it on your page, so there, it's dotted. So this dotted line is the y equals x line, and that's like the axis of symmetry for these two functions to be inverse of each other. If I folded the paper here, had wet ink, squished, that's what I would get. So I can see that this one has been flipped across the y equals x axis to create that one. Beauty. There's one other thing they want us to know here, actually. It says is the inverse of function. If you remember, a function is something that follows the vertical or passes the vertical line test. So if I'm going to take this line, this vertical line, and pass it along here, I can see that the black function passes the vertical line test because there's only ever one point of contact with this line. But if I look at the inverse of it, right there, and all the way along here, there's 2 points all the way along that point. They're parsed. So that means it fails the vertical line test, which means it is not a function. So that answers B. And then, of course, they want to know the domain and range. So if I look at the domain and range for the first one, the domain for this guy goes from negative 5 to 4. So I'll put my negative 5, x is in between negative 5 and 4. It means it's greater than or equal to negative 5, less than or equal to 4. And the range for that one, this way, goes from 0 up to 4. So y is in between 0 and 4. And for the next one, clearly going to be different since we switched it. So the next one's domain, oh wait, isn't this interesting? The next one's domain goes from 0 to 4. Weird. It's like we switched x and y. Okay, 4, or range. So we can guess that the range is going to be this, but let's have a look. The range goes from -5 up to 4. Yay! So you can see that the relationship for domain and range of inverse graphs is that the domain and range are also inverse. The domain becomes the range becomes the domain, because y became x and x became y.